that we have angles that are in terms of degrees, angles that are in terms of radians, right? We had two different things. Did it just get really dark?
Yeah.
Yes. Yeah. Oh, clouds are moving. All right. So we're going to draw this on our notes. We're going to draw two quadrants. Well, two sets of four quadrants, technically. And one of them is going to be radians. And one of them is going to be degrees. And they both start at 0. So this is going to be, goodness gracious. Give it a second. Ta-da. Okay. So we're going to have 0 radians, 0 degrees. And then what's this line up here? How many degrees is that? That's 90 degrees. This is a straight line from here to here, so how many degrees is that? 180. Okay, down here would be 270. And then when you create the full circle, you get to 360. All right, what did we say about radians? How many radians correlate to how many degrees?
1 pi correlates to 180.
Okay, so if this is from 0 to 180, then this would be from 0 to pi. So if this is from 0 to pi, 0 to 1 pi, what would the middle be? 1/2 of a pi. So we're going to write pi divided by 2. Okay, so we've got 0 to 1 pi, and then we've got another half, so what would be over here? All the way over. 2 pi. So we've got, this is 1/2, another half makes a whole, another whole makes 2, right? Okay, so we've got 1/2, another half would give you what? 1 1/2, which is 3/2. So we're going to say 3 pi over 2. Okay, so those are the measurements that we're going to work with. Yes?
What's the difference between putting 3 pi over 2 and then 3 over 2 pi?
If you do, so you can write 3 pi over 2, you could write 3 over 2 pi. Those are equivalent. Most math people are going to write it this way. Yeah. Hey guys, when he's late, we don't draw attention to it. We just let him come in so we can keep going. All right. So we're going to go ahead and make sure that we can draw some of these. Now, what I've noticed is that most students can draw angles with degrees using their common sense. But then when we switch over to radians, because it's all fractions, unless students are very comfortable with fractions, they have a hard time. Does that sound like what you anticipate will maybe be true for you? Okay, so here's some examples. We're just going to practice drawing these angles. So I'm going to give myself a quadrant plane right here. Coordinate plane, quadrants, 4 quadrants. I don't know what I should call that. A plus sign. I'm going to give myself a big plus sign to draw an angle in. And first, let's go ahead and draw a 132 degree angle. So if we label the quadrants, we have quadrant 1, 2, 3, and 4. And where would a 132 degree angle be?
Slightly above the middle.
Yeah, so it's in quadrant 2. And actually, if you know the exact middle, does anyone know the exact middle?
It would be a negative.
It'd be 135.
It'd be 135. 135 degrees would be right in the middle. How could you find the middle of 180 and 90?
Just add them together and divide.
Add them together, divide by 2. Okay, so 135 is right in the middle, and we're trying to draw 132, so where should it be? Slightly above. So this is a 132 degree angle. It doesn't matter. All right. What do you guys think I should do if I want to draw a negative 10 degree angle? You go backwards. Yeah.
Oh, well, I was
Everybody just yelled them out, yeah. So we go backwards. We're going to go down instead of up. There's a negative 10-degree angle right there. All right, let's say I want a 203-degree angle. 203. Where do we think a 203-degree angle would be? Third quadrant. Would it be halfway? No. It'd be less than halfway for sure. It'd be like this-ish. Now, when we draw these are all approximate. Nobody's actually going to get out a compass and double check your math, okay? As long as you're in the general area, you're fine.
As long as you're in the same quadrant.
Yes. So with this one, anyone know what the middle would be for that?
225.
225. Okay. All right. We're going to do a 361-degree angle. It's a full circle and then a smidge. Okay. So we're going to start here. We're going to go all the way around and then just boop. Just a little bit above. Okay. Now, we would say a 361-degree angle is coterminal with a 1-degree angle. What do you guys think coterminal means? It's like, yeah, it's in the same spot. So for each of these, I've drawn that line out. Do you guys see that from the center? That's called the terminal side of the angle. The terminal side meaning like it terminates there, it stops there. And so when I say coterminal angle, I'm saying they stop in the same place. So 350 would be coterminal for negative 10. So what Lily just said is if we go back to this one and we draw this angle right here, this is coterminal, but I drew the positive version. And so the coterminal angle would be 350. Does that make sense? So how far apart are coterminal angles? 360 degrees. They're a full circle away from each other, okay? So to find a coterminal angle in degrees, you add or subtract 360. So to get from negative 10 to 350, we would have added 360 degrees because we started with a negative angle and we wanted the positive coterminal angle. Does that make sense? For 361, we subtracted 360 degrees. We had a positive angle. We still have a positive coterminal angle. It's just much smaller. Does that make sense? Okay. Let's try another one. We're going to draw a 400-degree angle. Woof. Okay, so the way that these are a little bit easier for my brain is I'm going to think of 400 as being 360 plus how many degrees? 40. Okay, so I start off and I say, all right, here's my 360 degrees. And then how much further should I go? Like a little bit less than half. So I drew the 360 first, then I drew the 40. Does that make sense? Now if I look at it, 400 degrees and 40 degrees are actually coterminal angles because 400 minus 360 gets you to 40. They have the same terminal side. Same ending spot. So while the angle itself is technically not the same, the terminal side is. So for us, it appears to be the same. Okay. What if I do negative 600 degrees? We're going backwards. So we're going to do negative 360, and then how much more are we going to do negative? Negative 240. Okay. So if we go backwards, we're going to go backwards a full circle. And then we're going to go backwards 90, backwards 180. Do we go all the way to backwards 270? No. How far do we go? A little more than half. That's right there. So negative 600 degrees is coterminal with negative 240. So what I did is I took negative 600, I added 360 to it, and I got a negative coterminal angle. What would happen if I added 360 again?
You get one.
I would get 120, and 120, hold on one second, 120 is this angle right here, and that would be the positive coterminal angle. So this also equals 120 degrees. So if negative 600 is what I started with, negative 240 is a negative coterminal angle, positive 120 is a positive coterminal angle. Does that make sense? Yes.
So negative 240 is not the same as a regular 240?
Nope. Because a regular 240 would go up and over, and we went backwards. So a negative 240 is the same thing as a positive 120.
Negative 240 is the same as
A negative 240 is the same as a positive 120.
The spot is not
The spot is the same. The terminal side is the same. The angle is technically measured differently. Yeah. All right. How are we feeling with degrees? Can we draw some degrees on our own? Okay. We can try. Okay, we're going to do that first. So let's get started with some radians now. Whew.
That's where my easy
All right, so the first radian measurement that we're going to draw is pi thirds. The lighting got all crazy. The computer is confused. Give it a second. Okay, so if this is 0 and this is 1 whole pi, and up here is half of a pi, which is 0.5 pi, where would 1/3 pi show up?
No, actually, it would be closer to the top.
Which quadrant?
The first.
Quadrant 1, definitely quadrant 1, because this is saying like 0.5 pi, this is saying 0.333333333 pi, and 0.33333 is less than 0.5, right? Okay, so it's going to be like this, and it's going to be more than halfway, because halfway would have been 0.25 pi, right? Or 1/4 pi. Okay.
Well, you just split both of them into 3 ways, and that's technically 2/6. Right?
Yep.
Wait. Sorry.
So this is like 0.5 pi. This is like 0.333 pi. And then if we had right in the middle, that's like 0.25 pi.
Oh, so now.
So all I'm doing is I'm thinking, you can think in terms of decimals a little bit if that's helpful. You can think in terms of fractions if that's helpful. But I know that 1/2 goes straight up and down, and 1/4 would have been right in the middle, right? And so 1/3 should be in between those. That's all I was thinking, is I'm thinking the size of my fractions. Okay, here's our next one. 8 pi ninths. So this is 0 pi, this is 1 pi. How many ninths is 1 pi? 9 ninths, right? 9 ninths is 1 pi. So where should 8 pi be? 8 pi ninths. Just a little bit above it, right? If 9 ninths is 1 whole pi, then 8 ninths would be right above it. Yes.
I don't know.
Honestly, I'm probably not going to give you these problems on a quiz. I'm going to have you at the point we have a quiz, you should be comfortable working with the angles, but to be able to work with them, you have to understand them. So we're working on understanding them today. And then after this, once we start working with them, the actual working with it part is what we'll end up doing. Okay. All right. Let's go ahead and draw another one. All right, we're going to do 10 pi sevenths. 10 pi sevenths. Hold on, it feels blurry, so I'm going to see if I can fix it.
That was going to be my question. If you were going to do this weird stuff like that.
Yeah. Okay, so we have 0 pi. We have 1 pi. How many sevenths would 1 pi be? 7 sevenths.
3 more.
Uh-huh. Okay, so what if we were to go halfway?
It would be halfway.
It'd be 3.5, right? 3.5 sevenths? Okay. And then over here, if we did 7 plus 3.5, 10.5 sevenths. So it's going to be in quadrant 3, just a little bit before this line. Do you guys see how I thought through that?
Yeah. So do you always take the bottom number and just say like the 1 is it with itself?
Mm-hmm.
So it's always going to be like 9.
Yeah, so whatever, so this one, the 1 would have been 3/3. So we got 1/3, 2/3, 3/3, and then ninths, 1 ninth, 2 ninth, 3 ninth, 4 ninth. Yep. Okay. Let's try another one. We're going to do 12 pi 16ths. 12 pi 16ths. Do you want me to change it so you can't reduce it?
No.
We're going to leave it as 12 16ths so Ms. Rice doesn't change it. I was going to make it 17, so if you want to reduce it. Don't reduce it. All right, so this is 0. This is 1 pi over here. How many 16ths do we have?
16.
We've got 16 16ths. And the middle would be 8 16ths. So where would the 12 show up? Right in the middle, because it's actually 3/4. Yeah, okay.
No, don't do that.
I was going to turn it into 17ths if I needed to.
That was
But I don't want to only do odd. Okay. All right, let's try. You know what's coming next is those coterminal angles. All right. 17 twelfths. 17 twelfths. This is not coterminal. You have to have 2 angles to talk about coterminal, right?
Yeah.
17 twelfths. Okay.
Can you convert this into angles if you do
To degrees?
over,
You could convert it into degrees, but if you are so scared of fractions that you convert these into degrees always, then all you are doing is putting off the inevitable. Because in pre-calculus, you're going to have to deal with fractions. In calculus, you're going to have to deal with fractions that are like on crack. That's why I called them fractions. All right. So the fractions get like real convoluted later. We want to make sure that if we are on the honors track, we can handle this level of fractions. Does that make sense?
Yeah.
So if I were teaching this to an academic math 3, I'd probably actually have them convert them and just call it good. But they're probably not going to go the calculus route, you know what I'm saying? You guys probably need to be more comfortable with fractions. Yeah. All right, so tell me how I should think about this.
so the line, the other side of the x-axis would be 12 twelfths.
12 twelfths, okay.
And then the bottom is 18.
Okay, 18 twelfths. The top would be 6 twelfths. All these have a pi, right? Sometimes I get lazy and I don't draw my pi. Okay, so where should 17 twelfths be?
Close to the 18.
Okay. So here's our 17/12. What if I told you that I wanted the negative coterminal angle? So I want this one. Negative 5/12. Woo, okay. Now, don't say it out loud, Michaela. I want you guys to look at this for a second and see if... Oh, it shouldn't be negative 5. It was a typo. It was a typo. We knew what she was talking about. Okay. It was a typo, a verbal typo. It's fine. It happens. Mason, am I throwing that against the wall or no? No, we're putting that. Okay. So negative 7/12. Where did we get that from?
Well, you go back 6 and then just touch it.
I just have to touch it a bit.
Oh, so what Jackie was saying is this is 6.
Yeah.
And then that's one more. Okay. Or how many twelfths would it be if we had the 2 full pi? It'd be 24/12. Perfect. Okay, so when we find coterminal angles with radians, we are going to do the radian measurement that we started with, and we can add a full circle or subtract a full circle, and a full circle in radians is 2 pi. So the way that we got to the negative coterminal angle is we subtracted a full circle. Does that make sense? I took my angle, I subtracted a full circle. If I want to do this by hand, then I should say 17/12 minus, and what fraction would we write if we wanted it to simplify to 2, but it had to be in terms of twelfths? We would have to say 24/12. So if I want to subtract 2 and I want to do it by hand without a calculator, then I would say 17/12 minus 24/12. And then 17/12 minus 24/12 would give you that negative 7/12. So that's us getting the coterminal angle by hand. Okay. Depends if it's calculator active or inactive. Let's go ahead and grab a calculator. We're going to make sure we can do this on a calculator in case we're allowed to have one, and we want to save ourselves some time. So 17/12. Should I type the pi's in on my calculator? No, because once I do that, I'm going to have funky decimals. Okay. So 17/12 minus 2 whole numbers. And then I get a decimal. What do I do with that decimal? Turn it into a fraction. So I'm going to hit the math button. And this is what comes up. And I'm going to press enter twice. So enter for frac. And then one more time to get the actual answer. So negative 7 pi 12ths. Okay. So the reason that we are not typing in the pi is, again, it's going to give us decimals. We are using the calculator to combine like terms. These are both in terms of pi. We're using the calculator to put them together for us. Yes? Yes. Right. How do we feel about those radians? Those okay? All right. All right. I need somebody to give me a fraction that they would be uncomfortable with.
100 over 60.
All right, 100 over 60. That can be, we're going to say 100 over 62. No, maybe we're going to do 100 over 61, so it can't be simplified. Okay. All right, so what should I write? I've got 0. I've got 61 over 61. What's half of that?
30.5.
I've got 30.5 over 61. What's 61 plus 30.5? 91.5. Okay. So if we want to graph, I put this really close. Let me move it over. Okay, if I want to graph 100 over 61, Where should I graph it? Fourth quadrant. Should it be like really deep into the fourth quadrant? No, just like a little bit in the fourth quadrant. Okay. What would the negative coterminal angle be? So if I were to measure it this way, negative 22. How did Jackie get that? Somebody other than Jackie.
100 pi over 61 minus 121, which is like 2 pi.
122 over 61. Okay. And when you do that, you get negative 22 over 61. Okay. You did it the way where you were saying 100 to, yeah. You did the same thing, you just didn't do it, you did it more like visually versus mathy. Like, yeah. Okay. Let's try some of the negative versions. We're going to do negative 9 pi sevenths. So this is 0. We're going to go backwards, right? So this is 0. We go backwards. What's over here? Negative 7 sevenths. Okay, and then where should we end up? A little bit less in the middle. So negative 7 sevenths, and then 2 more sevenths. Because we're going backwards. I said we were drawing a negative 9 sevenths. So instead of going up and going positive 7 sevenths, we went backwards and did negative 7 sevenths. We're just drawing it backwards.
And so at the top is
Yeah, what would the positive coterminal angle be?
5 cents.
So why is it not 7 cents?
Because it's negative, we're going backwards. So positive 7 sevenths would be if we went this way. But we went backwards, so it's negative 7 sevenths. Kind of like if you were in degrees, you'd go backwards and say negative 180.
Yeah, okay.
So negative 7 sevenths. Every time a cloud comes, I have to change the lighting. Give it a second. There we go. All right. Let's go ahead and look at the next part on your sheet. 9 through 16. Let's see if we can do those. 9 through 16. All right. We are going to do 20 pi sevenths. Okay. So it's more than double. Okay. So before we go on, we're going to do kind of what we did with the degree measure. So if you look back at what we did with the degree measure, when we had the degree measure that was 400, we rewrote it as a full circle plus 40. See that? We rewrote it as a full circle plus 40. We're going to do the same thing. So a full circle in terms of sevenths would be how many sevenths? 14. So 14 sevenths is a full circle. So this is 14 sevenths plus how many more sevenths? 6. Because 14 plus 6 is 20.
Right above the other line.
Mm-hmm.
The second column.
And we're doing a positive version, so we're going to go up and over, right? So I'm going to start here. I draw a full circle. That's my 14 sevenths. And then how much further do I go?
Like a third or across.
How many sevenths is this right here? 7 sevenths. So we just drew 14 sevenths, and now to get 6 sevenths, we're going to go almost there, but not quite. Okay. How was that? Was that relatively?
It looks like a
Okay. All right, let's do negative 36 pi fifths. Ew. Okay, so talk me through this one. So negative 10 fifths. That's okay. So negative 10 fifths is one full circle. Negative 10 fifths again is another full circle. 3 full circles. And then how much more? Wait. This. Right? Negative 10, negative 20, negative 30, negative 36, right? Okay, so we're gonna count it. We're gonna count it up. Okay, so we got 1 full circle, 2 full circles, 3 full circles. We're going backwards. Okay. Now, when I go backwards, so I've done the negative 10, negative 20, negative 30, because I've done 3 full circles. And then when I go backwards, I'm going to get to negative 5 fifths. And how much more do I go?
A little bit.
Just a little bit more.
Okay, so I did that one.
That's very swirly. It's very swirly. Do we need another one of these? You guys are good at them? Okay. What if I say 72 17ths? Those are less comfortable. Those are less comfortable because the numbers are a little bit bigger. You could, but we're trying to not depend on the calculator so much. Okay. Yes.
So what makes it easier for me, so I just take the bottom number and just go 1, 2, so just add each number every
Oh, that's good. So he's saying he does 17 plus 17 plus 17 plus 7, however many times.
Yeah.
That's fair. Okay. So if we do, well, you talk us through it, Mason, okay? So we're going to do, we've got 17, and then Mason plus another 17 makes what?
34.
And then plus another 17? Mason, are we trusting you accurately?
You shouldn't let you
is 51. Okay, if we add another 17, what do we get?
68.
68, so we're gonna keep going, okay? Can we do another full 17? We cannot. Okay, so this over here is 17 17ths. How much do we have at the top? What's half of 17?
8.5.
Okay, so we are currently at 68 17ths, and we need to get to 72.
So it's actually around halfway.
Yeah, so we get like a little bit halfway, right?
No, a little less.
Little less than halfway. Because we needed to go 4. Oh, I did not draw that very well. We needed to go like this.
And then like a little bit more halfway in.
Okay. Okay, so that was the Mason method.
Yeah.
The Miss Rice method is 34 over 17 plus 34 over 17 plus, that's 68 plus 4 over 17. Okay. So 2 full circles and then a little bit more. Yeah, and that's the thing is like, but both of our methods do depend on you understanding how fractions work, which is why I like both of our methods. Is we're not scared of fractions, we're not avoiding them. We're making them work for us. Yeah.
Is there a way to do it?
You can convert it into degrees and then draw the degree measure. If you are planning on going on in math, you need to just get over the fear of fractions. You need to just work with them and get more comfortable. There is a point where if you work with fractions enough and you don't overly depend on your calculator, if you do them by hand enough, there is a point where you will get comfortable with them. But it takes a while. You have to not avoid them. You have to just do it. Okay. Yes. Okay. Before I set you guys off to work completely on your own, I want to make sure we can convert these. Okay. So let's go ahead and take 72/17 and let's convert it into degrees. So how do I convert it into degrees?
You multiply it by 180 over 5.
Yeah. How did you know that the pi should be on the bottom, not top?
Because it has on it.
I need to cancel. It already has a pi. I need the pi's to cancel. Okay. So to convert this into degrees, I'm going to put the pi on the bottom because then they will cancel. And so 180 and pi are the things that are equivalent. You could use 360 and 2 pi because we know that's a full circle and a full circle. Yeah. All right. So what do I type in my calculator?
Times 180, and then you divide by 70.
So you can do 72/17 times 180, and then you're literally doing the fraction times 180. Or you can do what you guys were talking about, multiply the tops, and then divide by the bottom. You get the same answer. And we expected this to be a pretty big number, right? Because we had to go around the circle multiple times. So that answer fits what we were expecting.
762.4 degrees.
Mm-hmm.
How can you do over how to do that? Me too.
How to go from degrees to radians?
You just put it on top.
Yeah. So let's go ahead and write this down, and then we'll do one converting to radians.
We were to actually write this on a thing. Would we just do 762 degrees?
Nope, I would round.
So 762.
I always do 3 because in calculus they always have you do 3. And so I do it now just to get you guys used to that being the norm.
We should just do 6.
No. All right. Somebody give me a degree measure.
5 million.
152. So with this one, I want to get rid of my degree bubble. I need to get rid of my degree bubble. So what goes on the bottom? 180 degrees, because then my bubble will cancel. Does that make sense? So here the pi goes on the bottom, so the pi's cancel. Here the bubble goes on the bottom, so the bubbles cancel. So we are not going to plug the pi in our calculator.
Oh, this is the one how we get to the fraction.
We're going to do 132, and then since the pi is being divided by 180, we're going to do 132 divided by 180. We're going to write this as a decimal. We're going to turn it into a fraction. Yep, math, enter. So this is 11 pi 15ths. You could say 11 15ths pi. People don't write it as often that way, but you are not wrong. Okay? Yep. Yes. If you want to type this in as 132 over 180, then the calculator will simplify it for you. It just comes down to what you're comfortable with. Okay. So at this point, you are finishing the worksheet. Okay? That's what you're doing the rest of the class is finishing the worksheet. Answer keys on the back. I'm going to go get the copy of your note. Yes. Yes.